My name is John Brian Almazan, and I am here to discuss the topic that was assigned to me, which is microelectromechanical system. Talking about the history of microelectromechanical system, in 1961, the first silicon pressure sensor was demonstrated. The invention of surface micromachining occurred in 1967. In 1980, it is when the first experiment in surface micromachining happened. Micromachining leverages microelectronics industry and widespread experimentation. So what is MEMS? So MEMS stands for Microelectromechanical System, which is a subset of microsystem technology that falls under the electronics and mechanics section. It is the process technology used in creating tiny or microscopic integrated devices or systems that combine mechanical as well as electrical components. So, microelectromechanical systems are fabricated using integrated circuit batch processing techniques and can range in size from a few micrometers to millimeters, and sometimes comparable to human hair. So these two given pictures illustrates or show how tiny these devices are.
Look closely and you will see them. Tiny machines, nearly invisible to the human eye. These micro machines make automobiles safer, insulin pumps for diabetics more accurate, and hearing aids more efficient. MEMS, or Microelectromechanical Systems, describes both a category of devices and the technique for manufacturing them. These tiny devices have elements ranging in size from 1 to 100 microns, about the thickness of a human hair. MEMS devices are generally divided into two categories: sensors and actuators. Sensor devices gather information from their surroundings, and actuators execute given commands or act generally through highly controlled movements.
So let's talk about microelectromechanical system transducer. Microsensors and microactuators are the very core of microelectromechanical system devices. Microsensors detects changes in the system's environment. It is the intelligent part that processes the information detected by the sensor and makes a decision in a form of signal. Microactuators are the one that acts on that signal to create some form of changes in the environment. Microelectronic components make up most of the intelligent part of the devices. Microelectromechanical system transducers are classified into five, which are the following: mechanical transducer, radiation transducer, thermal transducer, magnetic transducer, and chemical and biological transducer.
MEMS are made using the basic fabrication techniques and materials of microelectronics. Thin layers of materials are deposited onto a base and then are selectively etched away, leaving a microscopic three-dimensional structure. In this way, MEMS processes construct mechanical as well as electrical components. The electrical elements on the chip process data, while the mechanical elements act in response to that data. Hence, a complete system on a chip. Integrated circuitry provides the thinking part of the system, while the MEMS component complements this intelligence with active perception and control functions. Known as MST or Microsystems Technology in Europe and Asia, the potential for MEMS technology is endless.
Generally, what microelectromechanical systems do is that they sense changes in the environment via movement, vibration, temperature, etc. Then they think or collects information, process and analyze, and make decisions. And after that, they communicate by sending information or transmitting data, which is in a form of signal. Then they act or respond to the transmitted data and perform new changes in the system. Microsensors is composed of suspended mass between a pair of capacitive plates. When tilt is applied in the sensor, the suspended mass creates a difference in electric potential, which is measured as a change in capacitance. The signal is then amplified to produce a stable output signal. Microelectromechanical systems can be used in different types of application, which can be consumer products, aerospace, wireless and optical communications, automotive, biomedical, chemical, optical displays, and fluidics. So one of the specific application of microelectromechanical system is the retina prosthesis, in which a device or a camera is implanted in the retina of an eyeball, which enables one person to see clear images. Another application is a pressure sensor, which uses a flexible diaphragm as a sensing device. This can be used in automotive industry, wherein it is attached in one of the car's tire, which senses the tire's pressure and transmit data back to the consumer. MEMS can also be implemented in gyroscopes, which uses a vibrating structure rather than the traditional rotating disc to determine orientation. Another application is the PILCAM, which falls under the biomedical section. It is a small device that can help in medical diagnostics when ingested. Last but not the least application is the LOC, which stands for Lab on a Chip, which takes the laboratory testing of biomolecular sample such as blood, urine, and sweat out of a clinical lab and places it in a chip. So that is the end of my discussion about microelectromechanical system. Thank you very much.